Alright, in example 1, they want us to sketch the region bounded by the function f of x equals 2x. So that's a straight line with a slope of 2 and a y-intercept of 0. And they want us to consider this area bounded over the closed interval from 1 to 2. So let's take a minute and let's sketch that on our graph. So first I've drawn a ray emanating from the origin, and so this is kind of over the entire region here, but remember that the interval that we're concerned with is the closed interval from 1 to 2. And so let me demarcate those boundaries using some vertical lines. And one of the things that I also like to do is to shade the region that is bounded on the interval and under the function so that I can see exactly what it is I'm trying to find the area of. So here we have our bounded region. So in part B, they say if the interval from 1 to 2 is partitioned into 4 equal subintervals, what is the width of one subinterval? So what I want to do is take this width, which is going to be 1, and I want to divide it into 1, 2, 3, 4 equal intervals. Well, 1 divided by 4 is just 1/4. So that would be the width of one of my subintervals. In part C, they say if the interval from 1 to 2 is divided into n equal partitions, what is the width of one subinterval? And we're going to call that delta x. So remember that on the interval from 1 to 2, the total width of that interval is going to be 1 divided by n. And so this corresponds to our formula, which was b minus a divided by n. So in this case, the b is 2, the a is 1, 2 minus 1 is 1 over n. Finally, in part D, they tell us that if we call one of the subintervals the kth subinterval, so that's just an index. It can be any number between 1 and n of these n subintervals. They want us to find an expression for the right-hand endpoint of the kth subinterval. So what is that going to be? Well, if I wanted to find that point, I would need to start with my a value, which in this case is going to be 1. So we're going to start with 1. And we're going to add to that our delta x, which we just got as 1 over n. So 1 over n. And how many of these do we have up to the kth one? Well, we have k of them. And so 1 plus 1 over n times k. And so we can write that a little more compactly. 1 plus k